There's one thing up to now that I've been omitting. That's curves. That's because in 3D graphics there's no direct way to represent curves. If you have 2 points, it's very, very hard to actually attribute a function between those 2 points to represent a curve. And if you have a lot of complicated objects in a scene, having a separate function for every gap between 2 points becomes very, very tedious. To solve this, we use Bézier curves. Bézier curves are actually really simple. So let's start with something you really should recognize, a line. Now between these 2 points that define the line, we're going to have a third point. That's going to go from the point on the left all the way to the point on the right. Simple enough. So now we're going to have a line strip made of 2 lines. And on each line, we're going to have one of these points that goes from point A to point B. And they're going to do this at the same speed. That means that they'll start at the same time and they'll end at the same time, no matter how long the line actually is. So now we have 3 points, 2 lines, 2 subpoints. So what can we do with these 2 subpoints? We just put a line through them, right? And now, pretty sure you know where we're going with this. On this line, we're going to make another point. And this point is going to go through that line at the same speed as its 2 parent points go through their lines. So every point is going to start and end at the same time, no matter what the length of the line is. And even if the length of this subline changes, that means the speed of the point is going to change. It's always going to be at the same percent completion as the 2 other parent points. So its actual speed and its distance from the start doesn't really matter. All that matters is that its percent completion of its task is correct. So now we only have 1 point, and we can't make a line with only 1 point. So that means that this is our final point in the series. So what we're going to do with this point is make it leave a trail of wherever it's going to be in world space, and it's going to make it visible. And this is how you generate the simplest Bézier curve. Now the main points are called control points, and usually Bézier curves have 4 control points. And with that you can make an enormous variety of curves. And what's so great about these Bézier curves in computer graphics is, to create them, you don't have to use any formula that relates to a curve in any way. All we have are lines and points that iterate between those lines. Now you might say, yeah, but that final point is actually making a curve, so doesn't it know what path it's taking? And the answer is no, it doesn't. All it does is it follows its line. And wherever that line is, the actual point doesn't care. If it's supposed to be halfway through the line, it's going to be at halfway through the line, no matter what the orientation of the line is, no matter what the size of the line is. And it's just going to leave a trail of where it's going to be. And the final result of all these points iterating between lines makes a very complex curve. With a lot of these Bézier curves, graphing them is impossible with normal functions, because there are often 2 different values of y for a single value of x. And often even relations don't cut it. So you'll need either a lot of functions for different parts of the curve, or you'll have to go to the base of what a curve actually is, which is a summation of points. And a Bézier curve is exactly that. It's a summation of points. A basically infinite amount of points, because the final point knows where it is in world space. So for every instant, it's going to take that point and it's going to add it to the curve every instant. So like it'll seem like you have a continuous shape, but in reality it's just a bunch of points that are close together. And that's what a Bézier curve is.